Thank you, Christina. Hello, everyone. Hope you
Hello,
can hear
Simone.
me. Hi from Italy. And yes, thank you for having me. It's my pleasure to present these two CubeSat-based mission named ArgoMoon and LICIACube. And as I mentioned in the title, they moved Italian capabilities of operating satellites and having exploration mission, autonomous exploration missions in deep space. Because in Italy, we have a quite long-standing tradition of instruments development and also have a lot of activities with Earth observation and other Earth-based mission. But with these two missions, CubeSat-based, we were able to go beyond. And yes, currently we also have an interesting program for CubeSat development, but in the past season, we based our initiatives on opportunities. And in this case, the opportunities came firstly from the Artemis 1 mission. In fact, ArgoMoon, which is a 6-year CubeSat, was among the 13 ones that were selected for at the time was Exploration Mission 1, and then named Artemis 1, to be deployed at the first bus stop and to collect pictures firstly of the ICPS, one stage of SLS, and then having some orbital maneuvers to operate in the cislunar space and collect other pictures and testing technologies relevant for CubeSat in that environment. So these were mainly the mission objectives. And yeah, this was the timeline that we prepared in order to accomplish both the set of objectives. I can say that it was really challenging because at the beginning, there were lots of activities to be just after the deployment. It was expected to have a very fast setup with the update of the ephemeris and lots of other and online time on board. So it was really challenging. The design first is a 6U platform with the 2 optical payloads and 1 laser rangefinder with about a mass of about 14 kilos. Several were COTS subsystems and the others were in-house developments made by the Italian company Argotech. I think the core of the mission was on the software that was a 4-layer software that operating could identify objectives and keep them tracked maneuvering and having an autonomous targeting and attitude control. After 5 years of development, ArgoMoon has been delivered to NASA in summer 2021 and was installed in the Orion stage adapter together with the other CubeSat. I had the pleasure to participate in one of the launch attempt, one of the scrapped one, so not the last one, but it was anyway a very interesting experience, and I can say I was really impressed by the size of SLS. Being a launcher for CubeSat was really huge. I can say it was really impressive. Anyway, the final launch attempt was the one in November 2022. And just after the release, the satellite experienced a tumbling rate that was a little bit higher than a threshold that we put on board. So the 10 degrees per second. So the satellite entered right away in a safe mode for the first minutes, first phases. And so unfortunately, we were not able to capture the picture of ICPS. But in the past weeks, we collected, we maneuvered, we collected a lot of pictures of the Earth, of the moon surface, and we can say that and also the technology testing was successful. Meanwhile, in summer 2017, on the occasion of one meeting at the Italian embassy in Washington, D.C., there was a survey-promoted meeting where Italy was signing the association with the NASA survey. And I was there presenting ASI CubeSat for international cooperation, including ArgoMoon. And during the discussion with the APL team and the NASA team, Andy Rifkin was there presenting the DART mission. And the occasion, we started the idea of accompanying DART with a 6U CubeSat and the same size of ArgoMoon, which could support locally, acting as a local witness of the impact effect of DART on the asteroid Dimorphos. So LICIACube, after several weeks of assessment of the feasibility, we agreed that it was a good opportunity on both sides. And as you probably know, the target of the DART mission was the Didymos system, the Dimorphos asteroid. And what was expected was a release of LICIACube 10 days before the impact of DART, so that the CubeSat could have an autonomous targeting of all the elements in its field of view, and moving on an appropriate trajectory for a flyby could act as a witness, in particular for the ejection of materials, of the plume of materials released after the impact. This is what I've just described as ConOps. And here are the objectives, so including the eject plume monitoring, and also, for example, having a look on the not visible hemisphere of Dimorphos that was not visible from DART and also from the Earth. So we could able to collect pictures of this hemisphere, providing information also on the shape model of the asteroid and other relevant scientific information. We had a very wide cooperation, including the two agencies, of course, but also lots of national partners on both sides. So I mentioned Argotech, the firm, but also several Italian partners like National Institute of Astrophysics and University in Milan and Bologna. The most challenging part was the targeting, the autonomous targeting happening at about 12 millions of kilometers. And we also decided to pass at about the distance of 15 kilometers, so being safe with respect to the plume, but also having a good spatial resolution. Of course, navigation and orbit determination was very critical, and the accuracies were very challenging to be respected by the team. And,
Simone, about 1 more minute.
Okay, thank you. Sorry, I will quickly go describing the payloads and not the testing, of course, but we were able to deploy and participate in the launch in November. We had a very strongly interconnected architecture of ground segment. And I can tell that while just after DART impacted the asteroid, LICIACube collected very, very relevant pictures of the impact effect on the asteroid in terms of plume ejection. And we confirmed the DART impact and also had a very interesting set of pictures that allowed to have an interesting result also on the scientific side. 5 papers already published in Nature, and lots of work for the scientific communities to benefit of this set of data. So feel free to pose any question at the end. I don't think we have time now, and thank you for your attention.